Hello everyone, I'm Kusum Casey. Today me and my group are going to present on the topic flood potential across the Texas using the TOPSIS, and we are using optimization method and using the multi-attribute decision making. So the starting with the introduction. So flood has started to become extreme events for the past few decades, and looking for the Texas, it has like huge terrain variations and huge diversities. So it obviously includes the diversity in the weather condition. So diversity in the weather condition brings the varying flood risks across the region of the Texas. So for mapping the flood, we need to consider the various factors. So among the various different factors, we considered five main factors as our criteria for this project. Our first criteria was the precipitation, the second was the distance from the coast, then the land cover, county's mean elevations, and the urban imperviousness. So we took 254 counties of the Texas as our alternatives, and considering the impacts, how the criteria is gonna affect the county's flooding potential, we assign the positive impact or negative impact on that one. So the positive impact means it adds more, uh, it adds on the weightage of the flooding potential, whereas the negative means that it the relation is inversely proportional. So our main project's flow charts work like this. The first thing is we develop the criteria, which is our five main criteria as we described, and then we collected the data for these five main criteria for 254 counties of Texas, and then we carried out first is the pairwise comparison for doing the TOPSIS, and the second one is entropy method for doing the TOPSIS, and then we got our results. So for next.
Uh, in this part, we are gonna talk about the data collection part. Uh, so for our first criteria, the precipitation, we took the annual average rainfall in inches from the year 2010 to 2014 from latest data available online. And for the next one, distance from the coast, it was basically the distance measured in mile from the centroid of each county from the coast to the county. So we basically used ArcGIS for that and measured all the distance from the coastline to our 254 counties. After that, that for the land cover, we went on the MRLC website and use ArcGIS to create all the data. And after that, for county elevation, we again went online and took the latest data, which is the average elevation in inches for every county. And for the last part, urban imperviousness, we use the same process like extracting the land cover data from MRLC website. That data over there we used is from 2019, and that's it.
Hi, my name is Mason. Essentially, I'm going to go ahead and present to you the pairwise AHB and TOPSIS analysis, essentially what we did in order to rank all the criteria. So I'll go and start off with the figure you see here. It has the pairwise in one column, and then it has essentially everything else. So we use the Sati's method, the AHB way to basically rank each criteria. It's on a scale from 1 to 9. So essentially, it goes from equal importance, that's a ranking of 1, all the way up to 9, which is, extreme importance. Ideally, you want to answer in odd numbers since those give like strong preferences. So essentially, it makes it easier to determine like where you stand in terms of the ranking between, say, one criteria and another one. As mentioned previously, our five criteria were the precipitation data per county, the distance from the coast, essentially the mean value, the land cover as far as wetlands go, the land elevation, once again, the average land elevation per county, and then finally the percentage of urban imperviousness. Essentially, what we did was we developed five separate rankings, four internally amongst the four group members, and then, of course, one expert opinion that being Dr. Hernandez, of course. Okay, so next slide says pairwise AHP and TOPSIS is essentially a continuation of our process. So what you can see up here on the top left is essentially all our rankings from all our group members. And then finally, the expert opinion column is essentially what Dr. H considered as far as the pairwise comparisons go. And then finally, what we did was we essentially normalized all our criteria. So essentially, in this column, what you see, you have the largest column, or my fault, the largest value all the way to the smallest value, which speaks to, of course, the weight and how much it matters. So, of course, the larger the value is, the more important we considered it to be, according to our AHB and TOPSIS analysis. As mentioned previously, a plus just means it has a greater impact on flooding, like it is more positive affected, it essentially means it causes more flooding, and then a negative just means essentially it causes less flooding, basically, is how we did it.
For the next part, so we have calculated the weights in two methods. One was AHP and another one is entropy. So entropy, what entropy basically does is to look at the performance of the data for each alternative relative to each criterion. Entropy method calculates the weight by calculating the degree of diversification of the criteria, which is basically the complement of the entropy. So what we did was, after getting our data in this part, we had to just normalized all of the data and get to our weight. And this process was done through coding. Uh, we use R for that, and this basically gives us a comparison between the weights got in the entropy part and from the HP. From the previous part, we can see the precipitation had got the highest weight, but for this part we can see the wetland is getting the highest weight. So these two part, in the next slide, when we move on to the TOPSIS, will show us how our results vary if we are uh, if we are varying the methods of calculating the weights. That's it.
Okay, so this is the ranking that we got from the AHP TOPSIS method. As we can see, we have Harrison County coming up at the top, Jefferson, Orange, Dallas, and Liberty as the top five counties that are most likely to experience flood. And we have Hotspot, Presidio, Brista, Jeff Davison, and Culbertson as the list. If we look at the Texas map here, we can see that Central Texas is most likely to experience flood, and the northern part of Texas is least likely, while the southern part of Texas is just in the middle. Subsequently, we have the entropy state method, which also gives us a similar results, just a few variation in some of the counties, but Harrison and Hotspot is still comes up as top and bottom. The Central Texas counties are still most likely to have floods, and I think this would probably be because of the geographical location of Central Texas. There are major storms coming in from the Pacific Oceans, the Gulf of Mexico, and a strong frontal boundary coming in from the Great Plains. So basically, these two methods are just what we use to determine the flooding, the likeliness of flooding in Texas counties. So I think that should be it.